Okay, I want to do two things for my Zoom folks. First of all, if you can see me my screen and hear me, please raise your hand. Perfect. And could someone unmute themselves and just speak?
No.
Do that again?
No.
Perfect. Okay. I didn't get a single question from my Zoom participants in my last class, so I wanted to make sure that we actually had the ability for me to hear your audio. We do. Okay. Let's get started. And today, we, as promised, are moving into more advanced features of programming languages, and we will be talking about those more advanced features for the next 3 weeks. And we got 4 different topics: inheritance, module mechanisms, polymorphism, and generic functions, which is essentially how do you write templates, and then exception handling. So we are going to be comparing and contrasting how those features are supported or not supported in C, C++, and Java. So remember, this course, the title is Survey of Programming Languages and Systems. So this is part of that survey part where we're comparing and contrasting how different languages implement different features. So kind of looking at the design decisions. With inheritance, we're only talking about C++ and Java because C does not implement inheritance in any meaningful way. So we're going to spend the next 2 lectures or this week on inheritance. Today, I'm going to be talking about inheritance, an overview of inheritance. I know that most of you have probably seen inheritance if you took Dr. Greger's course. For those of you who took Planck, have you seen inheritance or not? Yes, no, who here took Planck? Anyone? You did. Did he cover inheritance? He did not. Okay. So my assumption is you have not seen inheritance in C++. If you've taken it from Greger, then some of what I say will be redundant, but I have to have everyone on the same page. Also, my guess is you have not had a general philosophical discussion about inheritance, how you should use it. So today we start out with the more general philosophical discussion of inheritance, how you should use it, and then I will talk about how it's implemented in Java. Then on Thursday, we're going to talk about how it's implemented in C++, and we'll talk about interfaces and how they work in Java. So let's get started with that. And basically, first of all, you often hear about object-oriented programming. And it turns out it means different things to different people. But in the programming languages community, it actually has a pretty well-defined set of characteristics. For a language to be described as supporting object-oriented programming, it must have 3 features. It must support objects, the creation of objects. So for example, most scripting languages allow you to create objects without actually creating a class associated with them. For example, in JavaScript, you can write something like A equals, and in braces, you could say something like, say, name, Brad, rank 3, and that would be an object without any class associated with it. So that's the first requirement. Second requirement is the ability to stamp out objects using a blueprint. That's typically called a class mechanism. So a class is not an object itself, but it is a template that you can use to stamp out or instances of objects. So when you see class person, string name, int rank. That's not an object, but it gives you the ability to stamp out instances of person. And then the final and most important, Ada. There's a language called Ada, not really used anymore, but it was developed by the Defense Department in the 1980s for defense projects. And it supported the notion of classes without actually supporting the third feature of object-oriented programming, which is the most important, and that is inheritance. So Ada supported classes, but not inheritance. So the programming languages community generally says that for a language to be object-oriented, it must have a notion of objects. It must have a notion of classes, and it must have a notion of inheritance. So inheritance is essentially the ability to create subtypes. Is the ability to create subtypes, new subtypes. Okay, so what do I mean by that? So first of all, I have to tell you what a type is, and then we can go from there. So a type is a set of values and a set of operations over those values. So for example, type int is integers, is a set of values. Set of operations includes arithmetic, comparison operations, those are the basic ones. Assignment. Strings would be a type, so they would be any set of characters enclosed in double quotes. Operations would be things like printing them, concatenating them, changing a character in them, so on and so forth. So then a subtype, actually can go to end of today's lecture for that. So a subtype is a type that permits the same values as another type, the same operations, and provides one or more additional operations. Okay, so a subtype is a little unusual in that it actually provides more operations. A subtype actually provides a superset of operations of the type. Okay. And then we have an abstract type, and an abstract type is one that specifies what its operations should do, but which provides no implementation of its operations. And I actually would like to add to that the provision that it also does not define the set of values. So I'm going to add to this and does not specify a set of values. It is a pure only operation. So for example, we can talk about a list that is independent of value, okay? It just stores some values. It could be a strings, it could be integers, it could be employees. So a list is an abstract type. Int is a concrete type. String is a concrete type. Stack, list, graph, they are abstract types. They specify a set of operations, but not a set of values. So inheritance essentially allows us to say, okay, we have this type, and now we want to define an extra set of things on it. So we might, for example, have an array. And we might define as a subtype stack and add operations like push and pop and top. That allows us to peek at the top element without removing it. So we'd say that stack is a subtype of array. Now, the way that programming languages have chosen typically to implement inheritance is using what is called a class subclass mechanism. So what you would say is that you have a class array, and then you could define a class stack, and somehow you specify that its parent class is array. In Java, you'd use the extends keyword. So you would say extends and that would say that stack is a subclass of array. So that's why down here you see me say classes, whoops, but not like that. Classes provide a concrete way to declare and implement types. So classes, effectively, each class declaration introduces a new type. And when you say that a class is a subclass of some parent class, you're saying it's a subtype. Okay, and we're going to find out that there are ways to specify abstract classes, and those correspond to abstract types. Abstract classes do not provide implementations for one or more of their methods. And we're going to find out on Thursday that another way to implement abstract types is through a mechanism called interfaces, but we won't worry about that today. Okay, but interfaces provide another way. Today we're mostly talking about classes. So when we say that a language supports inheritance, it supports the ability to create subtypes. Okay, and importantly is that a subtype must support all operations, declared by the type. And that is why we can always assign a subtype to something of type. If we say that stack is a subclass of array, then we can always assign a stack object to an array object. And the reason is that a stack object supports all the operations that an array supports. So it is always possible to assign a subtype to a variable declared as its supertype. Inheritance, typically, some other. Yes, go ahead.
Why would you do that? If you wanted a stack, why wouldn't you just say stack A equals new stack?
Because sometimes you want, okay, the question is, if I know that what I want is a stack, why not just declare that to be that variable to be right here? Why not declare this to be a stack rather than an array? And the reason is to make your code more generic. So at a later time, it may turn out that you want a different implementation for that. You don't want the array to be a stack. You want it to be something else. So a better example that probably would make it more clear is, let's say we have a list. And we set it a list A, and we make it equal to new linked list. And let's say that later it turns out that we figure out that all the operations either insert at the end or remove from the end, so that an array list would be better. Now, if you had declared this specifically as a linked list, you're going to have to go through your code, and if you have iterators or other things that are tied to a linked list, you're going to have to find every instance of them and change them to an array list. But if instead you had simply declared it to be a list, you would only have to change one declaration, and that is right here. So generally, we try to make things as general as possible to reduce the number of lines of code we might have to change down the road if we change our minds about how to implement that type. So that's the reason. Okay, here I was up here, you are right. I mean, probably if I really am treating A as a stack, it really should be declared as a stack. But oftentimes we have a more general sense of a data structure, and there we may want to be able to change it. Yes. Okay. Good question. So the question was, once I assign stack to A, am I now allowed to use the stack's operations? Am I allowed to say A dot push? And the answer is no. Okay, you're only allowed to use the operation in arrays interface. So you lose the ability to, when you assign a stack to an array type, you lose the ability to use the stack's operations. Okay, all you can now use is the arrays operations. And that is because at runtime, the compiler can't guarantee that A is a stack. You can assign other things there, and compilers aren't smart enough and can be never made smart enough to guarantee that A is pointing to a stack. So they make that restriction to make their lives easier. Okay. So with inheritance, you typically, not only do you get the operations, you also typically inherit implementation. Of the parents, of parent types operations. Okay? You are allowed to override or change. You are allowed to override. This implementation. Okay, and in a moment, so actually let's just get to it because it's easiest to kind of show you an example. So so inheritance is based on scientific taxonomies. The idea came from how you could go from general, like say animal, and then you might have canine, you might have feline. My knowledge of stuff, very scientific stuff, very quickly comes out. So we'll say wolf, dog, coyote. You might have retrievers, spaniels, terriers. Here we might have Labrador. Of course, I'm going to spell it Labrador, golden. You get the point. It's a taxonomy where you're going from most general to most specific. And it's a tree-like structure. So I come from, my research area was graphical user interfaces, and they provide a very nice example of a taxonomy. So at the root, you might have a graphical object, the top of the taxonomy. And then there's generally two basic types of objects. There are box objects, and there are line-like objects. And under box objects, you have things like rectangle, text, images. They're all box-like. Under line, you have things like line and polyline, which means multiple lines. Under line, you might have an arrow line. Under arrow line, you might have double arrow line, or a line that has double arrows. Under polyline, you might have open and closed. If you're wondering here's a polyline, a quadrilateral is a polyline. If it's open, here's an open. It's not closed. So this one is closed. This one is open. So that's a possible taxonomy. Now, let's start thinking about some operations you might want to perform. A basic one is draw. You would like to be able to draw an object. As you might imagine, there is no way to provide a implementation for a draw method of an abstract graphical object. So we would make this an abstract method, or it's often called a pure virtual method. We'll get to that. Then each subclass would have the option of either accepting the implementation or overriding it. Okay, again, box object and line object really can't draw anything, but a rectangle, a text object, and an image should all have the ability to draw themselves, but they would all use a different implementation. So in each case, they would provide a different implementation of the draw method. The same thing here, the line would be able to implement itself. Polyline would probably still be abstract, but now an arrow line is going to override the draw method. It will use the line's draw method, but it will add an arrow. And the same thing with a double arrow line, it will override the draw method for arrow line. So if I use an asterisk to denote a abstract, these would all be abstract. And the remainder are all concrete. They provide actual draw methods. Okay. Another one that we often care about is visible. Okay. That one is probably a method that we can define at the level of a graphical object. We can probably create a property called visible. And basically all subtypes would share that property, and there's no reason to override that method. We might have another method called contains point. And it turns out that a very nice default implementation for contains point is to take the so-called bounding box of an object and see if it contains the point. The bounding box is the smallest rectangle that encloses an object, the smallest rectangle. So here, the bounding box looks like that. It's not perfect, right? Because it will claim that anything in this area is part of that polyline when it's not. But for box objects, it's great. The because box objects essentially say that their area is the same as their bounding box. So they could take contains the default implementation for contains point and not override it. In contrast, a line object would almost certainly want to override it. Maybe not the line object, but a line can provide a better implementation of contains point, as can a polyline. They can provide a more precise implementation. And then it turns out that an open polyline and a closed polyline have the same definition for contains object. If you have an open polyline like this, when by default we assume for contains point that is closed with a dashed line between the two opens. So the open polyline and closed polyline could inherit or take the implementation from contains point. So what I've tried to show you here is three different kinds of methods. The draw method is going to be what we call a pure virtual method, or it's also called an abstract method. It is impossible to provide a default implementation for it. It will be overridden in all of the concrete classes. Is visible is at the other end of the spectrum. It will not be overridden by any subclass. It is something that we can declare as final at the level of graphical object to say no subclass should be allowed to override it. And then contains point is in the middle. It is possible to provide a default implementation for it that works for many of the subclasses, but that allows subclasses to override it should they so choose. So it's somewhere on the continuum between a completely abstract method and a fully defined method. Okay. So that actually leads us to some terminology. So we talk about three types of methods. We talk about abstract, or an alternative is called pure virtual. Okay, so types of methods. Okay, So no implementation provided. All subclasses must override or provide their own. Provide their own implementation. Then you have virtual methods. Okay, they provide a default. Oh. Nope. There we go. Provide a default implementation. That may be overridden, or maybe by subclasses. And the third type is called non-virtual. So this is 1, this is 2, 3 is non-virtual methods. And they provide a final implementation. That may not be overridden. And the type of method makes a difference with efficiency. We'll get to that in the next lecture, but basically, since virtual methods can be overridden, you have to wait until runtime to select the method that's going to be called because it all depends on the type of the subclass. But a non-virtual method means that the compiler can insert a direct jump instruction to that method at compile time because all subclasses, regardless of type, have to use that implementation. So non-virtual methods are the most efficient. Okay, so coming back, you can also, in addition to operations, you typically associate properties or instance variables with your classes. So here I had visible for the graphical object. Most graphical objects would also define a left, top, width, and height, even if they're a line object. It turns out to be helpful to have these attributes. But then a line object will probably choose things like x1, y1, x2, y2 to describe its two endpoints. A polyline might have an array of points. Probably a box object has a notion of perhaps fill color and a notion of line color. Certainly lines have a notion of line color. So a line object is almost certainly going to have the notion of a line color. Probably a line style in both cases too, like dotted, dashed, solid. So probably over here, line style. Then there's certain things that are unique. Text will probably have a label. An image probably has some kind of file that defines the image. An arrow line has some information. We'll probably have some information about the arrow, like arrow length and width. Okay, so on and so forth. Now, what you want to do with inheritance is factor out all the common stuff and move it to the super type. It's like algebra. If I have 5x plus 3x equals 10, I can factor out the x. Okay, common factors. So the idea is the same with inheritance. Here, once I'm done with it, I find that line color seems to, and line style seem to be common to both box object and line object. So in fact, I would move them into the definition for graphical object. So I would probably go through and for each, generally the way you do these declarations is you can work top down or bottom up, whichever you feel most comfortable with, but it seems that most people prefer bottom up. So it seems like generally you define all of your objects, at least with graphical objects. You define all of your objects, their properties, and methods. And then you start factoring out common properties and methods to superclasses. Whereas with something like a list, you might go the opposite way. You might go top down because you have a notion of what should be in a list, and then you might define some concrete implementations of a list. So the way, whether you do bottom-up design or top-down design, A, personal style, B, might depend on the type of problem you have. Okay, so that's kind of the idea. That's my philosophical discussion of inheritance. So again, what you're doing is it's giving you the ability to declare subtypes. The subtypes inherit the operations defined by the type. They may define additional operations. They may define additional instance variables. What they may not do is subtract operations or subtract instance variables. They can only add or modify the implementation of the methods. They cannot change the types of the properties, nor can they change actually the function prototypes, only the implementation. Okay, and inheritance creates a taxonomy. You factor out your common properties and methods into increasingly general subclasses or superclasses. Okay, and basically classes are a concrete implementation of types. Remember, a concrete type is a set of values and a set of operations on those values. An abstract type is a set of operations without specifying the set of values. Okay, one common mistake, actually some quick terminology, and then a common mistake before we move into Java's implementation. You'll often hear, so we have a parent class and the child class. Here are terms usually often associated with each. Parent classes are often called superclasses or a base class. You'll often hear a child class referred to as a subclass or a derived class. Okay, I will usually use the term superclass, subclass, or parent class, child class. But when you hear the words base class and derived class, they're referring to super and subclass respectively. Okay, so here's now the example of a common mistake. You have a rectangle, and you want to just create a square object. Well, you think, well, a square is a rectangle. It's just got a restriction that the height and the width be the same. So your first inclination is to make a square be a subclass of rectangle and to add something like maybe get size, which returns the size of it. But you don't want to support width or height anymore. You don't want to support get width. You don't want to support get height, nor do you want to support set width or set height. Instead, you want to replace those operations with set size and get size. So you don't want those four operations. That's a problem because the subtype has to support all operations that are defined by the supertype. So it turns out that this is the wrong relationship. So inheritance is called an is-a relationship. But there is a second type of relationship that the book talks about, which is a has-a relationship, and it's called composition. You use composition when you want to inherit implementation, but not interface. So composition is used when you want to inherit implementation, but not the parent's interface. Okay, so what is the interface? The interface is the set of all, is the interface equals set of operations, actually set of public operations provided by a type. It's often called API for Application Programmer Interface. And what you do with composition is you declare class square, and then you have it contain an instance of a rectangle. And then you delegate your calls to rectangles. So for example, with get size, so you might have int get size, and you could have that return r dot, it doesn't matter, width or height. Then you could have void set size, int size, and you'd call r dot set width with size and call r dot set height. For draw, you would just call the rectangles r dot draw. So it's called delegation. Essentially, what you're doing is delegating the calls to the composed object. But you're not supporting its interface. Okay, so with composition, coming back here, you delegate calls to the composed object.
I have a question.
Yes, give me 1 second. And if you go back here to the hierarchy, under box object, you would put square at the same level as rectangle. Square would be here. Rather than being a subclass of rectangle, it would be a subclass of box. Okay, yes, question now.
You've just answered it.
Yep. So square is a box object. Square is not a rectangle, but a square has a rectangle. So the way we say it is that a square is a box object. The relationship with rectangle is square has a rectangle. Okay, so composition is a really important design principle that complements inheritance. Okay, the same, I'll just warn you, the same thing comes up with circle and oval. You often think, oh, a circle is an oval with the same width and height. But no, a circle should contain an oval as a composed object. And a circle would actually be, again, probably an instance of a box object. So you got to be careful there. You have to support the complete set of operations of your parent. And if you can't, it means what you probably want is composition. You want to get the again, going back, composition want to get a hold of the mouse. Well, okay, composition is used when you want to inherit implementation, but not the parent's interface. Okay, any other questions about inheritance before I start into the Java implementation of inheritance? Okay, in that case, so in Java, the way that you have something extend or become a subclass is you say class B extends A. That makes it a subclass. When you declare your methods, if you want to declare them abstract, you put the word abstract. So if I want to declare a method draw as abstract, I would say abstract void draw. And that says I am not going to provide an implementation for it. If I want it to be virtual, like contains object, I could say Boolean contains point, and I probably need an int x, y. Here I would provide a default implementation. So this is a virtual method. This is pure virtual or abstract. And finally, a non-virtual method is declared final. So if I say final, Boolean is visible. Not only do I provide an implementation, but I'm saying that nothing may override it in any of the subclasses. And if you try to, Java will give you, the Java compiler will give you an error message. If you declare any of your methods abstract, you must declare the class abstract as well. Meaning you cannot create an instance of that class. And it makes sense because if I tried to create an instance of B and call its draw method, there is no implementation provided for the draw method. So that's kind of what's the runtime environment to do. So if you declare any of your methods as virtual, you must also declare the class as abstract. Okay, just like in, let's move on to the constructors. So in C++, you may remember that there is the regular constructors that are for initialization, and Java has those too. Same syntax. So you use the class name for the constructor. So no return type, and whatever arguments you want. Okay. Now, you may also remember that you're allowed to have initialization blocks that take no arguments, and you are allowed to assign values to your instance variables. So the order in which they're called is the initialization statements are first, the initialization block is second. It's like a zero argument constructor call, and the constructor is called third. If you have superclasses, their constructors are called before you. So in fact, I should say this is 3B because 3A is the superclass constructor gets called. So in fact, the very first constructor to get executed is at the very top of the taxonomy. And remember in Java, if you don't define a superclass, what is your superclass? You have one. What is it? Object. Very good.
Object.
Yes, object. Very good. Now, in Java, the way you specify what superclass constructor to call is with the super keyword and then a list of arguments. It must be the first line in your constructor. If you do not provide a call, Java will call the zero argument constructor for you, which means there has to be one in the parent. Okay, so if you do not provide, if super is not called, Java calls the zero argument. The rules for the zero argument constructor are the same as for C++. If you do not provide any constructor, Java creates a default zero argument constructor for you. As soon as you provide even one constructor, Java no longer provides a default zero argument constructor. So if you provide a constructor and you want a zero argument constructor, then you must explicitly declare and define it. This is exactly like C++. Okay, so like I said, you want to call the superclass constructor, it must be the first line in the constructor, and the call is to super. And any method can do the same thing. So for example, remember the arrow line. So I had a arrow line. The first thing the arrow lines draw method would probably do is call the draw method for a line. So probably what it would do is want to call super dot draw so that the lines draw method would get called, and then you would draw the arrow. So you're also allowed, when you're overriding, to call your super, and that doesn't have to be the first line. It can be anywhere you want. Okay, and let's see. Like in C++, Java defines an implicit this. So this is defined for all Java objects, an implicit pointer, or an implicit argument that points to the object. So for example, if you have to pass the object to another function, you would pass the this pointer. So just to reiterate, the way that you create a subclass is with extends. The way to declare a method as abstract is with the abstract keyword, and then you do not provide an implementation. If you do that, the class must be declared as abstract. Also, any subclass that refuses to provide an implementation for draw must also be declared abstract. So for example, back here, my taxonomy, box object and line object are not going to implement the draw method either. Therefore, they would also have to be declared as abstract. Okay, like in C++, okay, you only have to, the only methods a class should declare, a subclass are the methods it intends to override. So the only, I should say, superclass methods. Obviously, a subclass can provide new methods, but the only superclass methods a subclass should declare are the methods it intends to override. If it wants to accept the default implementation, it does not declare the method. If it is not going to define an abstract method like draw, it should not declare it. Okay. So actually, I have about 15 minutes and I am going to plow on because I do have some stuff that needs to be covered next time. So are there any questions here? Okay. What I want to do now is show the similar thing in C++, how you do inheritance. So in C++, if you want to have a class B inherit, then you say class B public A. This is important that you use the public keyword. If you don't, it will default to private. And what happens is that all public methods from A will become private, which isn't generally what you want. So this says that B, when you say public, you're actually saying that B inherits A's interface. Now, if you want, you don't have to inherit the interface. This is where you can make where C++ handles composition differently. So in C++, you can say class rectangle, I'm sorry, class square, protect it, B, protect it rectangle. And what this does, it takes all the public methods in rectangle and makes them protected. So all public methods in rectangle become protected in square. Okay, so we're now actually inheriting the implementation without inheriting the interface. You can remake methods be public. I forgot to look at how. I'll tell you on Thursday how to do that. So you're allowed to redeclare methods like draw to be public. But you can also then go ahead and declare methods like set size and now because it's inheriting, you would just say width equals S, height equals S, because at this point you have direct access to rectangles instance variables. So C++ provides an alternative way to do composition by using the protected keyword. That makes sense? Okay, but it also is then super important that in general, you want to support the same interface as your parent, and therefore you need to put public there because, like I said, by default, it will be private. One thing I forgot about Java, coming back here. When you declare your methods in Java, every single method, you must, if you want it to be public, protected, or private, you must prefix it. So if you want a method to be public, you must prefix it as public. If you forget to do it, it defaults to something called package level, which we haven't seen packages yet. So for the time being, you can think of package as being like private, but in fact, there are some subtle differences. If it's not part of a package, then package is just like private. But unlike, so you have to remember with every method and instance variable, you have to prefix it with public, private, protected if you want that protection level. Otherwise, it defaults to something called package level. Okay, in C++, if you can simply say, if you want stuff to be public, you simply say public, : And then anything after it is public until the next access keyword is used. Okay, so that's kind of nice about C++ is that anything after a keyword, an access keyword has that same access protection until you get to the next access protection. And by default, in C++, you get private. If you don't declare it as public explicitly or as protected explicitly, it will be private. Okay, with C++, the way to declare a method by default, okay, in Java, by default, methods are virtual. In contrast, in C++, by default, methods are non-virtual. It's kind of annoying, but it's the way it is. So going back to our three methods, draw, so to declare draw, it would be void draw. First of all, to make it virtual, you would say virtual void draw equals 0. That makes it pure virtual when you say equals 0. To make, so then for contains point, you would say virtual bool contains point. And for is visible, it would simply be bool, because by default, it is final. So this is non-virtual. And this obviously is virtual with the default implementation. So if there's not an equals 0, C++ expects the implementation to be provided. And if you remember in C++, class declarations by default goes in a .h file. Class definition, meaning function definitions, goes in the .cpp file. So that is virtual. We've now gone over how you declare a subclass. Okay, the next thing is constructors in C++. Tell you the truth, I don't think I have the time. I have 5 minutes. Okay, I am going to cut it off here. So I will get to C++ constructors on, actually, I did want to show you something. So let me, in the final 5 minutes, it was something I wanted to show you. C++ is a little pernicious, so I'm going to put everything into a .cpp file for a moment. I'm going to define a class A, and I'm going to give it int x, and I'm going to have the method I'm going to declare as here as a final thing int get x and have it return x. Okay, now I'm going to declare class B, and I will have B's constructor. We'll get to initialization list tomorrow, so don't worry. Have it call A's constructor. This is what's pernicious about C++. I am allowed to override, even though I declared getX as final, it's going to let me override X. GetX, I'll return -10. This is really crazy and stupid. So I'm going to say A star. Let's see, A star my A equals new A. I will call printf. I'll actually do this, cout my A get X line. Now I will assign to my A new B cout okay. So what you'd really like is for the C++ compiler to give you an error message here saying that you can't override it. But in fact, at least last time I tried it, which was not this year, you could get away with overriding it. And when you assign it this way, I believe you will get the X value. So we will make sure about that. So I didn't give it a value, so we'll give it 20. So I think done this way, because my A is declared to be of type A, I think in both cases it's going to return 20, print 20. Okay, that is my belief. I'm going to do, let's move this over here. Compile that. Winker. Huh. What's going on here? What's going on? Am I in the wrong place? Where am I? 365 play. Where am I in the other one? Oh, okay, we'll just compile it here. Lots of error messages because IO string. Come on, sorry. Class 6 errors. Ooh, that's because I'm forgetting my publics. See how easy it is to forget? You don't remember to make everything public, it becomes private. Ooh, look at this. Type A is not a director virtual. That's true too. Make it extend A. Well, that's nice. Okay, I'm over time. I'll figure out what's going wrong. It looks like for some reason it's not going to let me compile on this architecture. So I will revisit this on Thursday, but there's some small issues associated with virtual and non-virtual methods in C++ I want to show you. So Thursday, I'll pick up with this, go over constructors in C++, copy constructors and destructors, and then we will move on to interfaces. And we'll also talk about how virtual methods get implemented. Okay, so I'll see you Thursday. Good luck with Pet Detective. I have office hours today starting at 4:15. Remember, I might be a few minutes late, so if I'm not there right at 4:15, don't despair. I will be there. And also remember, the link for office hours is the 465 link, which is posted in the course announcements. And I will see y'all on Thursday.